All right, chem students, today we're going to learn about solubility curves. You need your blue notes packet and something to write with. Okay, in your notes packet, you have a solubility graph that looks just like this. It shows us increasing temperature going across the bottom and increasing grams of solute per 100 grams of water. Now, we can get a lot of information and ask a lot of questions about that information from this graph. So first, let's look here. Looking at this graph, in general, will an increase in temperature increase or decrease the solubility of a substance? Meaning, do we see things going up or do we see things going down mostly? What do most of them do? Well, we have most of them are increasing. So most things will increase. Now, which substances show the opposite trend, a decrease going across here? Well, there's two main ones that stick out. We have NH3 right here and SO2. Why do the substances from question 2 show this decrease? This is because they are gases. If you remember, gases will decrease in solubility as the temperature increases. Okay, question 4. Which substance is the most soluble at 10 degrees Celsius? So what I want to do is find 10 degrees Celsius here. This would be the least soluble, only 10 grams per 100 grams of water. So I'm going to go to the most soluble. I'm going to go all the way up here. The one up here is Ki. So Ki would be the most soluble. It can hold 135 grams per 100 grams of water. Now, which substance is the least soluble at 90 degrees Celsius? I go over here to 90 degrees Celsius. I want the least. So the very first thing I come across. Least substance would be SO2. Which salt is least soluble at 90? Now, you might say, I already did that one. Well, no, that was a gas. Remember, SO2 is a gas and technically a substance. They're asking for a salt. A salt is solid. So we're going to skip the gas and come up to this one. Is this a gas or a salt? That's going down as well. So that is a gas. So we got to keep going. We go all the way up to here. Sodium chloride would be the least soluble salt at 90 degrees Celsius. Now, question 7. Which substance shows the least amount of change in solubility from 0 to 100? So going across from 0 to 100, which one shows the least change, up or down? That would be this one. It's almost flat. So sodium chloride barely changes going across. Okay, question 8. At 30 degrees Celsius, 90 grams of sodium nitrate are dissolved in 100 grams of water. Is this solution saturated, unsaturated, or supersaturated? We're going to plot this point. So at 30 degrees Celsius, 90 grams. So I go to 30 degrees Celsius, I go up here, 90 grams, and I plot that point. Now, in relation to the line they're asking about sodium nitrate, which is that red line. Is my point above, on, or below that line? Below that line, right? So below the curve means that is unsaturated. I could keep adding solute until it gets to that point. So this would be unsaturated. Now, for number 9, at 20 degrees Celsius, 10 grams of sulfur dioxide are dissolved in 100 grams of water. This solution is considered to be what? Okay, so I'm going to go to 20 degrees Celsius. I'm going to go up to 10. 10 is exactly on that line for sulfur dioxide. So I'm going to say that is saturated. And for number 10, at 80 degrees Celsius, so way over here, I have 60 grams of potassium chloride. So go all the way up here. In terms of potassium chloride, the line for potassium chloride is this one here. Is my dot I just plotted above, on, or below that line? Well, if this is my line, the dot is above it. As you can see here, above the curve means it is supersaturated. For questions 11 through 14, we are going to need to be able to plot points again. Okay, question 11. How many grams of potassium chloride can be dissolved in 100 grams of water at 80 degrees Celsius? So I go to 80 degrees Celsius, and I want to know how many grams of potassium chloride. So I'm going to go up and find potassium chloride. Okay, that line is right here. So I'm going to go all the way across here. It looks like 50. I can hold 50 grams of potassium chloride in 100 grams of water, because it did say that in 100 grams of water. So 50 grams potassium chloride, 100 grams of water. Now, how many grams of potassium chloride can be dissolved in 200 grams of water at 80 degrees? So I already plotted that. I know it's right here, and I know it's 50. But they're asking for 200 grams of water. So it's going to be 50 times 2. So 100 grams of potassium chloride. And for question 13, they're still asking me about potassium chloride. How much can be dissolved in 500 grams of water? So it's still the same. I know I can hold at 80 degrees. I can hold 50 grams. So 50 times 5 would be 250 grams of potassium chloride. So with these questions, you've just got to be able to pay attention to how many times they want that amount of water to be included, because each 100 grams of water can hold 50, so I just scale that up as needed. Okay, for question 14, a saturated solution of potassium nitrate is formed from 100 grams of water. If the saturated solution is cooled from 70 degrees Celsius to 50 degrees Celsius, how many grams of potassium nitrate precipitate would be formed, meaning how many crystals would fall into the bottom of the solution? So we're going to look up 70 degrees Celsius right here, and we're going to go all the way up till we find potassium nitrate. So all the way up here. So let's say 140. So at 70 degrees Celsius, we can have 140 grams in solution. Now we're going to cool that down to 50. So at 50, which is right here, I'm going to go up, and it looks like I can hold about, let's say 85. It's right there in the middle. So at 70, I can hold 140 grams. At 50, I can hold 85. So that means I'm going to lose this much. So 140 minus 85. 55 grams of potassium nitrate crystals will form and come out of solution. Okay, that's it for today's video on solubility curves. Do the corresponding practice packet pages, and we'll see you for the next video.